Welcome to lesson 2.2. In this lesson, we're going to talk about factoring. Now, the most important key thing that I can stress right here is that factoring is the reverse of multiplication, aka factoring is division. That is something really important to understand. Whenever we say we're going to factor something, we're really dividing it out into two different things. It's the reverse of multiplication. So, quick review. From last lesson, we took things such as 7x squared times x minus 3. And then we distributed that in and multiplied it like this. So whenever I distribute, I'm multiplying in. And then we would simplify it. So we get 7x, oops, that should be squared, 7x cubed plus or minus 21x squared. So we distributed that 7x squared, multiplied it out to get our answer. Well, factoring is the opposite. Factoring is division. So let's look down here at these first couple examples. Now on this first one, I actually want to change this to a 3. Now the first thing that we need to do is look for what is called a GCF. GCF stands for greatest common factor. So the greatest common factor is the biggest thing they have in common. So if I look at this example right here, if I just look at the numbers, the -4 and the -16, what's the biggest factor or number that they have in common? Well, the biggest one they have in common is a -4. Now, this is a word that a lot of people use when we do factoring. I don't really like it. It's kind of a personal pet peeve, but we don't have a better word for it, so I'm going to use it anyway. At this point, a lot of teachers say we would take out a -4 because that's what they have in common. But usually if I say take out something, I think subtraction. If I have a bunch of apples and I'm going to take out some, I'm subtracting apples. But in this one case, when we say take out, I actually mean division. So if I am taking out a -4, what I'm really doing is dividing both of those by -4, by whatever I'm taking out. So if I divide this here, a -4 divided by a -4 is a +1. -16 divided by a -4 is a +4. Now there's one other thing that I can take out that these two things have in common, and that's an x squared. Both of them have at least 2 x's. So that is the biggest thing that they have in common that I can take out, is 2 x's, x squared. So I'm going to take out or divide both by an x squared. You always divide by what you take out. So in this one, my x squared divided by x squared is still just 1. But in this one, if I have x cubed divided by x squared, so that is 3 x's on top divided by 2 x's on bottom, cross out what I can, and I am left with 1 x on top. So this, -4x squared parentheses 1 plus 4x, that is this problem factored, because I took out everything that I have that they have in common. That is the greatest common factor, checking for a GCF. And every single problem you get to that you need to factor, you should always check for a GCF first. Very, very first. Always, always, always. Now, there is one other thing I'm going to be a little picky on with this problem before we move on. The inside is not in descending order. So I would want to rewrite it so the inside is in descending order. And I'm done. Now let's look at this one. What do they have in common? What can I take out or divide? Well, I notice both of them have a 9 in common. So I'm going to take a 9 out of both of them. This 27 doesn't have any m's, so I can't take out any m's because they don't have any m's in common. So I'm just going to take out the 9. If I take out a 9 here, I'm left with an m squared. And remember, take out means divide. And then take out a 9 here, or divide, I get minus 3. Double check the inside is in descending order, and you're done. That's it for that one. There's nothing else inside that they have in common that I can take out. So that means I'm done with the GCF. Let's try this one. Look at the numbers first. What do all the numbers have in common? The greatest factor that the numbers have in common. Well, they all have a 5 in common, so I can do that. Let me rewrite that actually. So I can divide them by 5. What's the greatest number of x's that they all have in common? So if I look, I have an x squared, x to the 6, and x cubed. So the greatest number of x's they all have in common is 2, so x squared. Same thing with the y's. I have a y to the 5th, y cubed, and y to the 4th. So the greatest number of y's they all have in common is y cubed. So I'm going to take out a 5x squared y cubed. That's the biggest thing they all have in common. And then what do I have left? So 25 divided by 5 is 5. X squared divided by x squared is a 1, so we don't need it. Y to the 5th divided by y cubed is going to be y squared. Next one, I have 35 divided by 5, which is a 7. X to the 6th divided by x squared, which is x to the 4th. And then a y cubed divided by y cubed, which cancels out because it's a 1. And then last one, negative 15 divided by 5 is a negative 3. X cubed divided by x squared gives me 1x left. Y to the 4th divided by y cubed gives me 1y. I can double check the middle. There's nothing else that the middle has in common. So that means I'm done with a GCF. In the next video, we're going to start talking about factoring quadratics using a very similar method to what we just did with the GCF.